All right, so for part 2 of your procedure, you're going to be doing what's known as an iodometric titration. This is a type of titration that will produce I2, or iodine, and basically what we're doing is we're looking at oxidation and reduction taking place. Now, from a technical standpoint, this really is not so different from an acid-base titration. And what I mean by that is you're going to be using a burette. Just as you open a burette with a base solution, it's going to be the exact same with your iodate solution. The fundamental difference is going to be the solution that's in your burette as well as the mixture of things that are in your Erlenmeyer flask. Now, if you watch, I've got my juice solution, the exact same juice solution that I used in my previous trials. I'm going to transfer 25 milliliters of it to this graduated cylinder. I'm going to transfer that graduated cylinder contents to our Erlenmeyer flask. Then I'm going to transfer some deionized water, another 25 milliliters of that, into my Erlenmeyer flask. So I've got 25 milliliters of the juice solution, 25 milliliters of DH2O. So I have a total of 50 milliliters. Now, here's where things get a little bit different. For an iodometric titration, you're going to be adding 3 additional solutions, but you're going to add 1 milliliter of each of those solutions. The first solution that you're going to use is known as Ki, or potassium iodide. We're going to use one of these plastic transfer pipettes, and if you look at the side of this, this has markings for 3 milliliters, 2 milliliters, and 1 milliliter. You're going to get 1 milliliter of this potassium iodide solution. Transfer that 1 milliliter, and nothing really should happen. The next solution that you're going to get is again 1 milliliter, but this is a hydrochloric acid solution. You're going to transfer 1 milliliter of the hydrochloric acid solution. So these 2 solutions really don't change the composition or the appearance of my solution, of my Erlenmeyer flask. The last one is a starch solution. Now this starch, the way that it's going to help us is it's going to be our indicator. So it is similar to or analogous to the phenolphthalein indicator. It's the starch that's going to change color. Well, what starch does is it binds I2. It binds to iodine. It doesn't bind to iodate. It doesn't bind to iodide, but it binds to I2, also known as iodine. So you're going to get 1 milliliter of this starch solution. The one thing that you need to be cautious of is this starch solution should appear homogeneous or homogeneous. In the event that it doesn't, swirl it up or mix it up by using your pipette. So I'm going to get 1 milliliter of this starch and I'm going to add it to my Erlenmeyer flask. And all that it really did was it made the solution a little bit cloudy. But the color didn't change or anything like that. At this point, the last thing that I need to do is work with my burette. Now, we're using 1 burette. So what that means is whenever you're done with part 1, so 2 trials of part 1, you need to fill this up with water and empty it out. Or put 5 milliliters of water into your burette, swirl it around, empty that out, add that 5 milliliters to the waste container. Then, what's helpful to do is equilibrate this burette with the iodate solution, KiO3 or potassium iodate. Add that KiO3 at approximately 5 milliliters, swirl it around to equilibrate the interior of the burette with that solution, then empty it out, add that 5 milliliters to your waste container. Then, once you've completed that, add your iodate to 0 milliliters and you're ready to proceed.